Hello dear students, today we are going to discuss about the most important proved head questions from exercise 8.4. Let's see the first question. We have to prove that sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1 is equals to 1 upon sec theta minus tan theta. So if you consider this left hand side here, the left hand side equation is in the form of sin theta and cos theta. And we have to convert into right hand side, that is in the form of sec theta and tan theta. So if you divide this equation both numerator and denominator with cos theta, so here this sin theta divided with cos theta, this cos theta is also divided with cos theta, and here 1 divided with cos theta, and in the denominator also we will divide with cos theta. So here we get sin theta divided by cos theta, that will be tan theta, minus cos theta by cos theta will be cancelled out, so we will get 1 plus 1 upon cos theta, that is reciprocal of cos theta, is equal to sec theta divided by here sin theta divided by cos theta, that is equal to tan theta. Cos theta cancel out, so you get 1, and here 1 upon cos theta, that is equal to sec theta. So now this left hand side equation is converted in the terms of sec theta and tan theta. Now see the next, here in the numerator in place of 1, here we have three identities. First sin square theta plus cos square theta equal to 1, second sec square theta minus tan square theta equal to 1, and third cosec square theta minus cot square theta equal to 1. Here we have sec theta and tan theta. So here in place of 1 we can write a sec square theta minus tan square theta. So here in the numerator this is tan theta plus sec theta as it is, minus here in place of 1 we will put sec square theta minus tan square theta. The denominator keep it as it is, tan theta plus 1 minus sec theta. So here this is tan theta plus sec theta minus this sec square theta minus tan square theta, that can be written as sec theta minus tan theta into sec theta plus tan theta divided by tan theta plus 1 minus sec theta. So here from those two terms, here tan theta plus sec theta, and here also tan theta plus sec theta, that can be taken common. Take tan theta plus sec theta is taken common. So here we have 1 minus this minus will multiply into the bracket, so it become minus sec theta, and here minus minus become plus tan theta divided by tan theta plus 1 minus sec theta. So here if you observe, in the numerator we have 1 minus sec theta plus tan theta, and here also 1 minus sec theta plus tan theta, so they are equal, so they will be cancelled out. So here we have tan theta plus sec theta, or you can write sec theta plus tan theta. Now if you see here in the right hand side we want sec theta minus tan theta. So if you multiply this equation with sec theta minus tan theta and divide with this m, so in the numerator here sec theta plus tan theta and sec theta minus tan theta, that become sec square theta minus tan square theta divide with sec theta minus tan theta. So we know the identity sec square theta minus tan square theta is 1. So here we got 1 divided by sec theta minus tan theta. That is the right hand side of the equation. So here left hand side of the equation is equal to right hand side of the equation. So this is a very important question. Let's see the next question. Similar to the first question, if you follow the same method as we have done in the previous question, you can easily solve this question. Here, this left hand side of the equation, cos A minus sin A plus 1 divided with cos A plus sin A minus 1. And here on the right hand side we have cosec A and cot A. It means we have to convert this cos and sin in the form of cosec and cot. So here if you divide this numerator and denominator with sin theta or sin A here, then here cos divided by sin, that becomes cot. Here sin A will be cancelled out, and here 1 upon sin will be equal to cosec. So first step is divide the numerator and denominator with sin A. This cos divided by sin, that become cot A. Here sin A will cancel out, become minus 1. Here 1 upon sin A, that become cosec A divided by cos divided by sin, that become cot A plus sin A cancel out, become plus 1, minus 1 upon sin A, that become cosec A. So here in the numerator, this is cot A plus cosec A minus, here in place of 1 we will put cosec square A minus cot square A. Denominator, keep it as it is. So here this is cot A plus cosec A minus this cosec square A minus cot square A, that can be written as cosec A plus cot A multiplied cosec A minus cot A. That A square minus B square become A plus B, A minus B. And in the denominator, your cot A plus 1 minus cosec A. Now here in the numerator, this is cot A plus cosec A. Here also cot A plus cosec A. That can be taken common. So here remaining is 1 minus, this is cosec A, and here minus minus become plus cot A divided with cot A plus 1 minus cosec A. So here this 1 minus cosec A plus cot A here, so 1 minus cosec A plus cot A, that will be cancelled out. So here we get cosec A plus cot A. This is what we have on the right hand side of the equation. So this way we can prove left hand side is equal to right hand side. Let's see the next question. Prove that tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta is equal to 1 plus sec theta into cosec theta. So let's start with left hand side. Here on the left hand side we have tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta. So we have to convert this tan and cot in the form of sec and cosec. So first let's convert this tan and cot in the form of sine and cos. So we can write that tan theta as sine theta divided by cos theta, and here this cot theta can be written as cos theta divided by sine theta. Here cot theta, that can be written as cos theta divided by sine theta, and here 1 minus sine theta divided by cos theta. So if you simplify this, in the denominator, if you take the LCM, this sine theta will multiply with 1. So here we will get numerator as it is, sine theta divided by cos theta, and in the denominator we will get sine theta minus cos theta divided with sine theta. Same way here, cos theta divided by sine theta divided with cos theta minus sine theta divided with cos theta. Now here this sine theta is the denominator of the denominator, we will go into the numerator, and same way here this cos theta will be going to the numerator. So if you simplify this and rearranging this equation, we will get is sine theta into sine theta, that is sine square theta, and in the denominator we have cos theta multiplied sine theta minus cos theta, plus here this cos theta multiplied cos theta, cos square theta, and here we have sine theta multiplied with cos theta minus sine theta. So here if you want to take LCM, here we have sine theta minus cos theta, and here we have cos theta minus sine theta. So here if you take the negative sign common, then this plus will become minus, and here we have cos theta and here we have sine theta. So if you multiply and divide this with sine theta and this with cos theta, then the LCM become sine theta multiplied cos theta into sine theta minus cos theta, and in the numerator it become sine square theta into sine theta, that is sine cube theta. This plus sign become minus, and here cos theta into cos square theta, that become cos cube theta. Now here we can use the identity a cube minus b cube, that will be equal to a minus b into the bracket a square plus b square plus ab, and in the denominator we have sine theta multiplied with cos theta into sine theta minus cos theta. So here this sine theta minus cos theta will be cancelled out. Now this sine square theta plus cos square theta had become 1. So here we get 1 plus sine theta multiplied cos theta divided by sine theta into cos theta. So here if you take this sine theta into cos theta to both of this, here we will have 1 upon sine theta into cos theta plus here sine theta into cos theta divided by sine theta into cos theta. So here this sine theta cos theta cancel out, here we get 1. So this is what we have, 1 plus here 1 upon sine theta, that become cosec theta into 1 upon cos theta, that becomes sec theta. So this is what we have on the left hand side, right hand side. Hence this question is proved. Let's see the next question. Prove that 1 plus sec a upon sec a is equal to sine square a upon 1 minus cos a. So here on the left hand side we have the equation in the form of sec A, and on the right hand side we have sine and cos. It means we have to convert the sec in the form of sine and cos. So we can write this sec A as 1 upon cos A. Now here in the numerator, if you take the LCM, this becomes cos A plus 1 upon cos A divided by 1 upon cos A. So here this cos A is cancelled out. So on the left hand side we get 1 plus cos A. Now if you observe, on the right hand side we have to prove sin square A upon 1 minus cos A, and here we got 1 plus cos A. So if you multiply it with 1 minus cos A and divide with 1 minus cos A, so here in the denominator we will get 1 minus cos A, and in the numerator 1 plus cos A into 1 minus cos A, that become 1 minus cos square A. We use the identity A plus B, A minus B, that become A square minus B square. So this 1 minus cos square A on the numerator, that become sin square A upon 1 minus cos A. So this is what we have on the right hand side. So by using this simple method you can prove this type of questions. Let's see the next question. Question is, prove that under root of 1 plus sin A upon 1 minus sin A is equal to sec A plus tan A. So if you start from left hand side, here on the right hand side we have sec and tan. It means we have to convert the sine into form of sec and tan. And first of all we have to remove this square root. So here if you multiply and divide this equation with 1 minus sin A, so if you see here in the numerator 1 plus sin A, 1 minus sin A, so it become A plus B, A minus B, that become 1 minus sin square A square minus B square, and in the denominator 1 minus sin A multiplied with 1 minus sin A, that become 1 minus sin A whole square. So here 1 minus sin square A, that become cos square A divided with 1 minus sin A whole square. So here this square and under root will be cancelled out. So we will get, this will be equal to cos A divided with 1 minus sin A. Now we have to convert this in the form of sec and tan. We have to prove this will be equal to sec A plus tan A. So to prove this, multiply this with 1 plus sin A and divide with 1 plus sin A. So if you do this, here we will have cos A multiplied 1 plus sin A. In the denominator 1 minus sin A, 1 plus sin A, that become 1 minus sin square A, A minus B, A plus B, that become A square minus B square. So here this in the numerator cos A, 1 plus sin A, and in the denominator we have 1 minus sin square A, that become cos square A. So here 1 cos A will be cancelled out. So here we will have 1 plus sin A divided by cos A. So you can write 1 upon cos A plus sin A upon cos A. So this 1 upon cos A, that becomes sec A plus sin A upon cos A, that becomes tan A. So this is what we have to prove on the right hand side. See the next question. Prove that sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta is equal to tan theta. So if you consider here the left hand side, clearly we can say here in the left hand side, if you take a sine theta common, so here we will have 1 minus 2 sine square theta, and in the denominator if you take cos theta common, so we have 2 cos square theta minus 1. So here sine theta divided by cos theta, that become tan theta, and now we have to take, this should be equal to 1 minus 2 sine square theta, and here in the denominator we have 2 cos square theta minus 1, that should be equal to 1. So write it as it is here. Now here convert this sine square theta in the form of cos square theta. So we can write this sine square theta as 1 minus cos square theta. The denominator, take it as it is. So if you simplify this, here numerator, multiply this 2 into the bracket, so it become minus 2 and minus minus plus 2 cos square theta divided by 2 cos square theta minus 1. So here this is 2 cos square theta, and here 1 minus 2, that become minus 1 divided by 2 cos square theta minus 1. So here 2 cos square theta minus 1, 2 cos square theta minus 1 cancel out. So here we got tan theta. That is what we have on the right hand side. Hence the question is proved. Next question, very easy question. Sin a plus cosec a whole square plus cos a plus sec a whole square is equal to 7 plus tan square a plus cot square a. So here first of all use the formula a plus b whole square, here also a plus b whole square. So this become, in the left hand side, it become a square plus b square plus 2 a b plus here also this a plus b whole square, that become a square plus b square plus 2 a b. Now you can see here sin square a plus cos square a, that become 1, sin square a plus cos square a, that become 1. Here this cosec square a, and here we want to convert into tan and cot. So cosec square a, that can be written as 1 plus cot square a, this is 2. Sin a and cosec a, they are reciprocal of each other, so they will be cancelled out. Here we have sec square a, so that can be written as 1 plus tan square a, and here 2, and cosec a and sec a are reciprocal of each other, so they will be cancelled out. So here we have 1 plus 1 plus 2 plus 1 plus 2, that become 7 plus tan square theta plus cot square. So a here, tan square a plus cot square a, that is what we have on the right hand side. Let's see the next question. We have to prove cosec a minus sin a into sec a minus cos a is equal to 1 upon tan a plus cot a. So here we can write this cosec a minus sin a. So cosec a can be written as 1 upon sin a minus sin a. This is on the left hand side equation. Same way here sec a, that can be written as 1 upon cos a minus cos a. Now here if you take the LCM, this sin A will multiply here, that will become 1 minus sin square A divided by sin A. Here this cos A will be multiplied here, so it becomes 1 minus cos square A divided by cos A. So this 1 minus sin square A had become cos square A, and here 1 minus cos square A had become sin square A. So here if you cancel out this sin A and sin square will be cancelled out, here cos A and cos square will be cancelled out. So here we will get, this will be equal to cos A multiplies sin A, and we have to prove 1 upon tan A plus cot A. So how will you prove it? So we can write this divided by 1, and here in place of 1 we can write sin square A plus cos square A. Now if you divide this numerator and denominator with cos A into sin A, divide with cos A into sin A. So here in the numerator cos A into sin A, cos A into sin A will be cancelled out, and here in the denominator this sin square A divide with cos A into sin A plus this cos square A divide with cos A into sin A. So here this sin A will be cancelled out, so we get sin A upon cos A, that will be tan A, plus here cos A cancel out, so here we get cos A upon sin A, that will be equal to cot A. That is what we have to prove on right hand side. Let's see the next question, the last question of this lecture. So to prove 1 plus tan square A upon 1 plus cot square A is equal to 1 minus tan A upon 1 minus cot A whole square is equal to tan square A. So let's prove it. Starts from left hand side. Here we have 1 plus tan square A divided by 1 plus cot square A. So we know that 1 plus tan square A will be equal to sec square A, and here 1 plus cot square A, that will be equal to cosec square A. So sec square A, that can be written as 1 upon cos square A, and cosec square A, that can be written as 1 upon sin square A. So this sin square A will go into the numerator. So here we got a sin square A divided with cos square A, that is equal to tan square A. That is what we need to prove here on the right hand side. Also second thing here we have to prove 1 minus tan A upon 1 minus cot A whole square is also equal to tan square A. So here if you take this left hand side equals to 1 minus tan A upon 1 minus cot A whole square. So this is 1 minus tan A, and here in the denominator this cot A can be written as 1 upon tan A whole square. Now here in the denominator if you take the LCM, this tan A will be multiplied here, so we get tan A minus 1 divided with tan A whole square. So here this tan A will be going to the numerator, and this 1 minus tan A minus 1 is cancelled out, so here we will get minus tan A whole square, and that will be equal to tan square A, which is given on the right hand side. So this way we can prove this question. So these are the different important questions which can be asked in the exam.